The graph of a function is shown together with the tangent line at the point P. Estimate the derivative of f at the corresponding x value. We are finding the derivative of f, which is f prime, but only at the point P. We don't know what the x-coordinate is at the point P precisely. It is a little bit more than 2, but it's not quite 2. But graphically, it does not matter because if we are estimating the derivative of the function f at that point, all we need to do, again graphically, is to draw the tangent line at that point, the tangent line to the curve at the specified point. In this case, the line is already drawn for us. Notice that the line cuts the graph at this point also, but it doesn't matter. We are only interested in the area around P, and this is already a good tangent line. Once we have a good tangent line, we pick any 2 points on this line. But usually we pick the 2 points that we can identify the coordinate easily. In this case, those are the points that are at the intersection of the help lines. And so this point is on the line and its coordinate is easily identified. This is when x equals 0 and y equals 0. We can pick any other point, but again, the idea is that we want to pick the point that we do not have to spend too much time identifying the coordinate. In this case, the next point on the line should be this point, whose coordinate is easily identified at x equals 1, y equals 2. We can pick any other 2 points as long as they are on the line. And so f prime at the point P is approximately using the slope of the tangent line, which is delta y over delta x. This is an approximation. The change in y is y2 minus y1, and the change in x is x2 minus x1. And this is 2 over 1 or 2. We say that the derivative of the function f at the point P is 2. Suppose now we are looking for the derivative of the function at this new point here, whose tangent line is not drawn for us. At this point, x is 1, 2, 3, 4, 5. And this is when x equals 5. And so we're looking for f prime of 5. Unlike the previous derivative, in this case, we will need to draw the tangent line ourselves. If we draw the tangent line, try our best to draw a straight line that goes through this point and just touches the graph at this point only. And then we extend the line a little bit longer and pick any 2 points on this line. This point is on the line, and again, its coordinates are easily identified. This is when x equals 5, y equals 5. Y go from 1, 2, 3, 4, 5. And then we would pick another point. In this case, we run out of the help lines or grid lines here, so we will pick this point for example. Even though this point is not at the intersection of the 2 help lines, but this is the best we can do given the limited viewing window. And we estimated that at this point, x is 4 and y is about 5.75 or perhaps 5.7, but it is not quite 5.5. And so maybe we'll just simply use 5.7 instead of 5.75. Now that we have the coordinate of the 2 points on this line, we will just simply do rise over run. We have to be consistent here. If we call this left point the first point, then the next one has to be the second point or the ending. The change in y is the ending y minus the beginning y, and the change in x is the ending x minus the beginning x. This is negative 0.7 over 1, or simply negative 0.7. And so we would say that the derivative of the function f at x equals 5 is negative 0.7. It is negative because the tangent line is moving downward.